Imagine it's a beautiful and sunny afternoon in South Florida. Kids are playing, families are planning their trips to the beach, but all of a sudden, clouds start surrounding, and it's only a matter of minutes for when streets start to flood and accidents start to occur. Here in South Florida, this isn't just an occasional inconvenience, it's a constant crisis. The change and rapid change and unpredictable weather patterns are a problem for our communities. They're putting our citizens at risk, especially because they don't have a tool to get informed and real-time data to make informed decisions, such as should they evacuate or should they stay put in situations like this. Do you want to tell them about our solution, Daniel?
Sure. So Alan, if you go to the next slide, we worked on a web app that provides real-time local data. And next slide, Alan, if you could. So if you have a moment, we'll give you a second if you want to scan it. This is, you can take a look at it. Now, Alan, if you can exit out and change the next tab, we'll show you how it works. And this is a view of it. Now, hello? Okay. So if you think about floods, one of the main things you have to worry about is your car getting stalled out. If your car is underwater, it no longer works. So we first ask you just quick information about your car, and we weren't able to plug into a database of cars to get the clearance height, but that would be our goal. And then once you complete your year, you would then, from there, be taken to a map that starts overlaying some helpful data. So let's start here. This is a standard Google Maps data, nothing very interesting, but we're gonna add some layers to it. So first we're gonna add, if I'm in Miami, I wanna see also what's the traffic data looking like. That's also provided by Google, but now we wanna actually see where are accidents overlaid, where are they happening? And if we actually activate that, that's Miami-Dade Police Commission's feed of live accidents happening today. So you can actually see, those are probably the places where you don't wanna drive because you don't wanna see the accidents. This is actually the same feed that probably feeds the news. But now you can access it on your phone, you can access it on the domain. But now we want to add one other thing. So we did talk a lot about how public resources maybe aren't as great, but one resource that Miami-Dade has is amazing. It actually has charted maps that allow us to see things like this. So we can actually see, if you go to the next one, this next layer, groundwater, this actually is an overlay, and you can actually move the map around if you want, Alan. You can see where the groundwater is lowest. So it means where areas can take in more water or take in less water, which could pose a factor in terms of what's going to flood. And then let's remove that layer, Alan, and then now add storm surge. So this is the indicator of where storm surge areas are most common. So these resources exist, but they're not overlaid together. We only have a place for static data and we have a place for dynamic data. But now we're trying to build a place where you can see both those things overlaid, okay? Google Maps exists, AccuWeather exists, weather.com exists, but the main difference is that we plug into local community data that we don't usually get from these feeds because it's impossible for them to scale and do this. So we're gonna pass this now over to talk about tech stack.
Our tech stack, front end, Next.js. But the magic happens on the back end. Rust, Redis, MongoDB. We have taken caching away from the front end and we have minified one of the hardest of the two hardest things in software development. Naming things and caching validation. So we do our caching with Redis. We want to expand our app in the future by adding rain data from the federal government's weather API, where we can go in the past and look at past data, feed it into our AI or our LLM to try to predict where the flood's going to be in the future, where you can avoid it. Thank you.